you were at Meta, extremely huge company, extremely unique data problems. How has the process gone, or how has it been different being inside of that large scale of a company to now likely working with smaller companies relatively compared to Meta?
It's been great. It's been different. And there's a lot of advantages for working for a company like Meta. Okay. Meta is a tech company first and foremost, right? It's a tech company built by tech people. The CEO is coming from engineering background, which makes a big difference, right? In some of the companies that you see out there, the CEO is not coming from a tech background. They don't understand that, and technology is supporting function to support the business. And Meta is a company where, and not just Meta, I think if you look at Microsoft today and Google and other companies, they're tech companies first. So there's a lot of emphasis on tech. There's a lot of emphasis on solving tough problems using technology, which is amazing. When I joined Meta, it must have been like 8 years ago now. I think that the data platforms and tools that Meta had compared to what's available in the industry was a complete game changer. It was a completely different level. Meta had bigger problems to solve because of the sheer amount of scale and sheer amount of data that they have. And just to give you an example, right? Meta had built an internal technology for streaming, right? Because because the volumes and the amounts of data that they needed to stream, and that was the backbone of the entire data warehouse at Meta and the entire warehouse. And the amount of data was so large. It was terabytes every second or whatever. So it was too much for every technology. And I was talking to the guy who was the head of the data streaming team in data infrastructure, and I asked him, why don't you use Kafka? I mean, I'm coming from companies where Kafka is best in breed, and he said it is the best in breed, but we stress test Kafka to see how much we can push it. And at the time it was like, he said the limit was at around 100 gigabyte per second, and we need orders of magnitude more than that. So it just didn't work for us. I think if you look at Spark, Meta was early adopters of Spark. They realized the potential, but they had an entire team of 2, 3, 4 people, whatever, who were contributing to Spark. So the version of Spark that Meta was using was always slightly advanced compared to the rest of the industry, and they would always, push these features into the open source version. They had Presto, which was at the time cutting-edge technology. They built it because there was nothing else. But I think at some point, what's interesting, at some point the industry caught up. So if you look at what's available today, you look at Databricks, you look at Snowflake, you look at BigQuery, you look at, even tools like dbt and Airflow, and a lot of tools that the industry didn't have 8 years ago, 10 years ago, they exist now. And actually leaving Meta, I was really surprised, because I was leaving Meta and I thought I'm going to go back. But actually what's available today for most companies, even smaller companies, is cutting edge as far as I'm concerned. So the industry had really caught up with the technology.
Yeah, but back then, a lot of the openly available, whether commercial or open source options, they were designed for 99.9% of the use cases, but Meta and other similar sized companies, that's the 0.01%. Which I think even reminds me too of I think a post from Zach that he once did about like, hey, the problems that you're likely going to be dealing with, they're not going to be the same scale as the ones that Netflix does, or the ones that other of these writers are writing about, right, from their experience, right? Because the setup for the team is going to be different. The technology stack is probably going to be different size, scales, problems. And if for folks that are trying to find a job, you don't necessarily, unless you're targeting one of those super high up the food chain companies, you want to learn what you're actually going to encounter in the field. So
even though I would say that every system has its limits, right? And it may not be at the same scale as Meta, but I think that processing, I don't know, 800 petabytes per day of data with 50,000 servers or whatever, I'm just making up number, I don't know what the number is, can be the equivalent of processing 5 gigabytes per day with one single server. So you may be working for a smaller company, but if you're hitting the limits of your system, and if you're at the edge, if you're like at the 99% of what your system can do and you need to optimize, you might be applying the same tricks as Zach is doing on Netflix and Airbnb and Meta and, you know, big tables and, you know, using a lot of these principles and ideas because you don't have a choice, because you're hitting the 99% limit of your system.
Correct. Yeah. And I think it ultimately comes with the concept, right, as like, is this the best engineering solution for the outcome that we're trying to get to, right? Because you don't want to over-engineer. You know, you can't, if you're in a smaller company, you can't try to design your tech stack around something that involves a lot more resources than your team is ever going to have, right? And, you know, like, you know, you're not necessarily, depending on the size of the company, you're not going to have a dedicated site reliability team. I'm sure Meta and others have like multiple of those teams. But for a lot of organizations, depending on the size, they might have one person, maybe. It, you know, just different size problems.
Yeah. And I think what's interesting is, I did talk about it recently, but there's something interesting that's happening right now at the cloud age, which is basically your systems are almost no longer constrained, right? So in the past, when I had my database and I had the limited amount of storage, and if I wanted more storage, I needed to get more disks and I needed to connect them, and I needed to set them up and build more table spaces so I can build more like I could create more tables in my database. So I was always constrained, right? The database had a specific limit in terms of size, and that was it. And I had to get the maximum value for that size. And today, your system is very elastic. So it can basically grow indefinitely, right? You want more storage, you just, you know, you click and you choose more storage. You want more compute, just ask for more compute, you get it. So I think that we lost something with it. It makes it so much easier, because for me, adding 20% more storage to my database was like a 2 months project. And today it's non-issue. At the same time, we're less incentivized to optimize, and we're less mindful towards costs, because it's just no longer a problem, and companies prefer to throw more money on their platforms and keep growing them, but deliver more features. You will see, you know, in a lot of, you talk to a lot of data engineers and data teams, and they say, oh, we want to spend time performance tuning our queries or refactoring things that are built in a scrappy way. And our PMs would tell us, no, it's not a priority right now. We need to ship more features. And it's that exact mindset, because there's no constraint, right? It's not a problem for them.